Welcome to the AI4EO Cafe for live presentations around AI. Today, the speakers are Nicolas LONGEPE, Phi-lab Explore Office, Directorate of Earth Observation Programs at the European Space Agency. And I also welcome Annekatrien Debien, Project Director of the AI4EO project, with a talk on ESA's AI4EO initiative, bridging the gap between the AI and Earth observation communities. So again, hello, hello.
Hello. Good afternoon.
Hello, everybody who's joining today. I'm very happy you're all there. This is, of course, our AI4EO Cafe, and it's interactive. So everybody who's here, please feel free to ask questions to the speakers during their presentations. And I'm going to read the questions afterwards to the speakers. Small rules here. Please take notice that the session will be recorded. No confidential information shall be shared in this cafe session. In this cafe, the speakers express their personal view and opinions. It's not necessarily the official AI4EO project opinion. My name is Carmen McWilliams. I'm the moderator and organizer of this cafe. And I'm also the director of the company Grassroots Arts and partner in the European AI4EO project. So what is this web cafe about? As you know, it offers live web sessions which take place regularly, weekly basically. The cafe is an online forum to gain insight into the European AI scene. Participants get the chance to share knowledge and experiences and meet stakeholders from various areas of AI research and application. So now I come to the, of course, highlight of our cafe today. I will introduce the speakers. So again, great you're here. Thank you, Nicolas, you're here. Thank you, Annekatrien. Now I'm going to introduce Nicolas and afterwards Annekatrien, and then I give the microphone to Nicolas to start the presentation. Nicolas LONGEPE received the M Engineering in Electronics and Communication Systems and the MS degree in Electronics from the National Institute for the Applied Science in France, both in 2005. Then he received the PhD degree from the University of Rennes, France in 2008. From 2007 to 2010, he was the Earth Observation Research Center of the Japan Aerospace Exploration Agency in Japan. From 2010 to 2020, he worked at Collecte Localisation Satellite, France, as a research engineer in the radar application division. Since September 2020, he is now with the Phi-lab Explore Office, Directorate of Earth Observation Programs at the European Space Agency. His main scientific interests include Earth observation with a focus on SAR imagery and digital technology such as machine deep learning. He has been working on the development of innovative EO-based applications for environmental and natural resource management, ocean, mangrove, land, and for forest cover, soil moisture, snow cover, permafrost, and for maritime security. So, welcome, Nicolas. This is a pleasure to have you here.
Thank you, Carmen.
Thank you. And Annekatrien also introduced. Normally the lady first, but this time we do the other way around. So now Annekatrien is the project director of the AI4EO contract with ESA. She has a master's in bioscience engineering from the Catholic University of Leuven, with a focus on Earth observation. She has worked as a service development manager, developing satellite-based ice monitoring at Kongsberg Satellite Services from 2011 to 2015. Afterwards, she started as Space Tech Partners, where she was in charge of training and information sessions on the EU Copernicus program and the Copernicus Support Office. Her interests include user education, innovation, and European Earth observation sector. So also great. Welcome, Annekatrien. It's a pleasure to have you here.
Thank you.
Thank you. And now, for everybody who is a little bit impatient, we start now. I will hand Nicolas the moderator role, and it's up to you, Nicolas, to show us your presentation. Yes, I already see PowerPoints. Maybe main screen. Yeah, main screen is.
So can you see?
Fine. Perfect. Perfect.
Okay, thank you very much for this introduction, Carmen. So together with Annekatrien, we'll try to give you an overview of the AI4EO initiative, so how we can bridge the gaps in between the AI and the Earth observation communities. So you all know that we are living an AI revolution. This is about self-driving cars, DeepMind, and all the robots that pretend to behave like a human being. So this is actually our new electricity. Why we have that? Because actually there are the convergence of three aspects. The first one is that there is an overwhelming amount of data, which are mostly coming from internet. And you all know about this ImageNet database. We have an increase of the computing capabilities, mostly driven by Moore's law and the fact that the number of transistors in dense integrated circuits actually double every 2 years. And and there is this algorithm which are now available. We are talking about a zoo of algorithm made by GAFA, Google, Facebook, Amazon. We are talking about PyTorch, TensorFlow, Keras, and so on. So basically, within this talk, we mostly use computer vision deep learning stuff, and we start from this basic stuff, and we want to decipher and know what is within the image. It can be cats, dogs, and so we build neural networks, and finally you come up with a solution with cats, right? You can even determine, for example, the species of the cat, refining the architecture of the networks, and so on. So for sure, there is we have this black box effect because for now, you know, there is some kind of trust regarding this AI, and this is even a topic of research because people are looking at how we can fool actually the AI algorithms. So you introduce some noise or some artifact on the image, just like with this banana on the cat, and then you have some alternative answer from the networks. People are looking about the explainability of the AI box, and also this is a research of interest about how we can introduce actually physics information within this AI box. We are still looking for robustness and also reliability, which is very important. And actually, there is still some bias, I will say, in the methodology because it strongly depends on the database which is used as input. So if you have some bias as an input, then you will have probably some bias as an output. So anyway, within the AI, within the EO Earth observation community, we would like to use this AI because it's very, very powerful. And actually within the community, here the idea is actually to use AI to get some new insight about the planet Earth and all the issues that human being is actually facing. It can be ocean bloom, any new impact, fire alerts, forest loss, ship detection, ice melting, and so on. So there are so many issues on the planet Earth, and we aim to use AI to get new insight on this. And actually, yes, there is a rise of the AI within the Earth observation community, and here is the number of papers related to deep learning within the remote sensing community, and you see this is almost exponential. We want to actually use AI to accelerate actually the insight for Earth observation. And it can be about the detection, classification, it can be about big data analytics, super resolution enhancement, it can be about emulation, parameterization, data science. And last but not least, and I will come back to that later, is about onboard autonomy. And actually at ESA, we are building and actually for the European Commission, and thanks to the European Commission, a set of satellites, especially the Copernicus mission, which is the Sentinel. You have the Sentinel-1, which is a synthetic aperture radar sensors. You have Sentinel-2, which is a multispectral imager. Sentinel-3 is mostly for the ocean. Then you have Sentinel-5P, which has been launched quite lately about the atmospheric content. You have also Sentinel-6, which has been launched maybe 1 or 2 weeks ago about the ocean topography. On top of that, you have the so-called Earth Explorer mission. You have GOCHE that measure the gravity field of the Earth. You have the SMOS, which is about the soil moisture, and also the salinity. CureSat is about sea ice. Anyway, you have a collection of satellites that exist, and you have also all the meteorological satellites in high altitudes and METOPS and so on. So in addition of all these systems, you have also the small satellites, nanosat, CubeSat, and also you have drones, apps, high altitude pseudo satellites platforms. So basically within the AI for EO, we want to integrate all the data coming from these sensors and get new insights. So basically, we mentioned about this neural network that can decipher in between dogs and cats. And actually, we have as input a data cube. It can be any data that are actually produced by these satellites. We want to use that data cube to get new insights. It can be about crop classification, oil palm monitoring, can be about shape, ocean, or whatsoever. So we extract that information to get new insights, which are useful. And actually, at the Phi-lab, we conduct a set of study cases for different users. It can be NGO or other partners. And here I will just briefly introduce some few study cases, and starting from this one, which is about the mapping and the monitoring of infrastructure in desert area. So basically here we use Sentinel-1 images, which is a synthetic aperture radar. So this sensor actually penetrates. You have the capability to be used day and night, whatever the cloud coverage. So you may use a stack of images, and thanks to that stack of time series analysis, then you can actually build and train some neural networks. Here we use the new UNet networks, which is fully conventional networks. And at the end, you train it against, for example, OpenStreetMap dataset. And finally, you are able actually to decipher and detect all the infrastructure in one specific region. We build also some big data analytics here, for example, counting the number of planes in the airport and trying to assess the impact of, for example, the COVID. We can build also some application to detect some land use or land cover change. And on the top left, you see some modification due to the building construction in Wuhan during the COVID. Thanks to this, let's say, intelligence, we can monitor, for example, the oil tanks, and we can compute the percentage of oil storage and do that thanks to radar, and then thanks to also to physical modeling as well. We have also some different projects with UNICEF or WFP. Lately, they have been conducted some drone campaigns in Malawi and Mozambique. And the idea of this project is actually to use these drone campaigns where they put simply a camera to identify the crops. And actually, thanks to the combination of the drone images and the large-scale Sentinel-1 or Sentinel-2 images, then actually you can produce a large-scale information about all the crops that you have over one given area. So it's really the fusion in between the drone and also all the satellite images. Thanks to this techniques, AI, and for example, CNN convolutional network, you can actually try to mimic the job of sea ice analysts. You know that in the Arctic region, you have some national sea ice services that produce daily some sea ice chart for mariners. And basically the aim of this this project and activities is actually to try to mimic their job and try to automatize this process. So basically, it is choose as input radar images, and as output, you can see the classification of the sea ice concentration, which are quite fair, identical to what is actually produced by the Danish Meteorological Institute. One aspect which is very important is about enhancing spatial resolution. This has been an active field of research within the computer vision community, and basically the Earth observation community is currently embracing these technologies to get super resolution images or downscaling. And in this example, you see actually how we can actually create some super resolution data coming from a time series of multispectral images. A way also to use deep learning and especially GAN, generative adversarial network, is to try to see through clouds. The idea of this data set that we are building is to be able to reconstruct missing data when you have time series from multispectral images. The thing is that these sensors are very sensitive to clouds, so for some specific date, you don't have any images, but still you have the synthetic aperture radar that work day and nights. So the idea is to combine the information in between the Sentinel-1, the radar, and the Sentinel-2, the optical sensors, so that when you don't have any optical images due to cloud, then you can actually reconstruct it thanks to the information that you have from the radar. And you can actually perform that thanks to, for example, GAN or other techniques. Another way to use deep learning and we'll say machine learning is actually to use it for emulation. And the idea of this project is actually to replace radiative transfer model, which are used in different retrieval schemes. So basically, you build neural network that are able to simulate what will give a physics model. So you have the main advantage that is very fast to train and very fast also for the invariance, and also it can actually perform better results. What we are building as well at ESA is that so as you can imagine, AI actually is fueled by annotated data set. We need training data to have these algorithms. One way to do that is actually to use annotation tools. So we have developed a suite of projects to get annotation from these satellite images. It can be on the web, it can be also on smartphone. Here you see an example with this project game.io, where the user actually on this smartphone has to decide whether he sees a slum or not in the picture. One way to do that is also to do crowd sourcing and gamification, and we are developing a project with a Blackshaw company where you combine gamification, gaming, and actually Earth observation data annotation. We develop also a suite of tools for the conversion of different information, and also there are some tools which are now available on the internet and that enable you to download very easily all the data that are produced by the Sentinel mission, especially Sentinel-2, and you may look at this EU Learn initiative. We are also building some tools to ease the handling of synthetic aperture radar, because it's not so trivial, I will say, to use it, and also you will need some expert knowledge. So the idea of these tools is actually to simplify this works and to produce what we call RRD, so analysis ready data sets, so that you just need to use that tools, and then all the data is ready for being used within deep learning frameworks. Last but not least, and this is a very hot topic actually, is about AI at the edge. So an AI quote Peter Splatzer at the last, the Phi week in 2019, and he said that the value of satellite-based EO no longer grows with the ability to collect and transmit data back to Earth, but it's increasingly lies with the ability to transmit customer relevant insight in real time. And you may know about this experiment that ESA conducted with some European partners is about embarking an AI chip on board a satellite. And actually, this satellite, which is called Phi-sat-1, was launched in September this year. And actually, we put an AI chip on board, and you have these hyperspectral images. And the idea is actually to filter out all the data that are polluted by the cloud directly on board, so that you can only transmit the useful information. So we use the Myriad 2 Intel VPU visual processing unit, and the thing is that with that chip is very small, as you can see on this picture. So it's very convenient for small sat and all nanosat satellites. So as a way forward, AI can really accelerate the time to insight for the Copernicus program and all Earth observation data. As I mentioned, different of you, how can we make some progress on that? So there are different ways to do that, and especially at European level, and more specifically at ESA. What can we do? We can try to create actually a data ecosystem around this AI4EO. We can provide research industries, institutions with the data. I think that we already do that. And as I mentioned, the idea is to remove the barrier for data preparation, training, data creation. So we are building some software, we are building some smartphone apps, and so on. We can also try to build some interdisciplinary ecosystem at European level to bring all the different partners all together. And last but not least, we want also to conduct a suite of research and innovation activities, trying to accelerate actually the technical evolution of the capabilities in Europe and foster the uptake of AI within the EO community. And to do that, we can support fundamental research in AI4EO and work on specific and dedicated EO problems. We can develop a set of use cases, as I've shown you previously. And last but not least, and that will be the main goal of Annekatrien's presentation, it will be also to develop a suite of AI challenges, trying to address data scientists and innovators to work all together. And you may all know about this Kaggle and Kelvin or other crowdsourcing platforms, and we have also a different ambition here, and we want to create our own ESA platform so that we will gather all these communities jointly. I think this is it for my part. I'll leave it now to Annekatrien, which we will present the AI4EO initiative and this platform.
Yes, thank you, Nicolas. I'm now giving to Annekatrien the moderator role. One moment, Annekatrien. Thank you. Questions we answer later. So first Annekatrien and then the questions. So now Annekatrien is, you are now the moderator.
Yes.
Yes.
You see my screen?
Perfect.
Thank you, Carmen, and thank you, Nicolas, for the introduction to the Phi-lab. I will be talking a little bit more about the AI4EO initiative. I know Nicolas has mentioned AI4EO already a few times, but the specific scope will be this this project that we're handling at the moment, that is really meant to support all of the objectives of the Phi-lab. So why are we doing this project? So what we are going to do to support ESA is really building an AI4EO ecosystem whereby we gather the communities of Earth observation and AI experts to solve key scientific questions together and grant societal challenges. And the reason for this is that there's a little bit more complexity in Earth observation data than it is in, for example, cat and dog pictures. Earth observation data, Nicolas has shown all of the satellites that are available. A lot of those satellites have been designed specifically to address or to measure certain parameters. They also take pictures in different wavelengths to measure different surface parameters or the health of vegetation, for example. And so there's a lot of information, not just the color of a pixel, but there's a lot of information within that value of the pixel available in satellite imagery. And for that, you really need to combine Earth observation expertise and the AI modeling. So we're aiming to bring those two communities closer together and to really create an environment whereby they can exchange ideas, work together to raise awareness about the challenges with Earth observation that can be tackled using AI technology. And the way that we will be doing this is first and foremost by building this community, a community that will last throughout the project in different platforms, such as Twitter, LinkedIn, but also through the AI4EO platform. And then the AI4EO platform will then also host the challenges. And these challenges, for the moment, we have 3 that are in pipeline, and they will really focus on specific topics, specific societal issues that Earth observation can tackle and for which AI could really bring an added value. We're building this for and with ESA, together with a consortium of companies that have a lot of background in Earth observation, but also in AI and innovation. Soon, so we've been working on this project for a few months now, and in a month and a half, we're aiming to launch the very first challenge of AI4EO, which is focused on air quality and health. And that's based on a need that was expressed by the European Centre for Mid-Range Weather Forecasting, which is managing the Copernicus Atmosphere Monitoring Service, so at an EU level, providing analysis and forecasts of different air quality parameters. But the challenge for them, or that they see, is those data sets, they cover really large areas, they're updated every day, but the size of the pixels is very large. And if you want to use that air quality information, that free and open air quality information at a local level, you need to downscale it. And models exist, or you have models that also use in situ data that really bring down the air quality information to a more city level, but you don't always have in situ data, and it takes a lot of modeling power, cloud computing power to reach those downscaled levels of air quality. And so that's what we're hoping to aim to get now from AI, to get from the participants ideas and solutions on how AI can tackle this problem, to downscale 2 specific parameters, particulate matter and nitrogen dioxide. And so for this, the first challenge we will open up in February 2021. And the challenge, so participants will have time to for 3.5 months to come up with their solutions and submit them to our platform. We're hoping to have, or everyone can work together in teams. Also, you know, even if you are not in a team already, but you have some AI expertise or some Earth observation expertise, you can join and team up with others on the platform. And of course, to start with, because this is bringing together two different communities who, you know, the AI experts on one side and the Earth observation experts on the other side, to really get people started and to inform them and make sure that they understand the details and the peculiarities of Earth observation data. We'll have an introduction webinar at the launch. We'll also have support throughout the challenge on a forum, through an email address, and last but not least, while we're hoping for some open science solutions here, of course, any team can join, even companies, and the IPR of the solution will stay with the challenge participants. We're just looking for inspiration and some good ideas to really bring this field forward. So to go a little bit more into detail of the technical part of the challenge. So as I mentioned, we're going to look into downscaling or improving the resolution of two different products, which is the particulate matter, which is fine dust, to translate it a little bit, that we will get that you get from the Copernicus Atmosphere Monitoring Service, which is available in 10 by 10 kilometers over Europe, or even 44 by 40 kilometers outside of Europe. So if you look at a more city level, that's of course 2 cores. Or the other data set that we'll look at is nitrogen dioxide measurements from the Sentinel-5P satellite, which come at a spatial resolution of 7 by 3.5 kilometers. So again, very useful and scientifically valid information, but not always applicable at a local level. And we provide those data sets, those training data sets, for 3 different areas of interest. We're looking at northern Italy. Perhaps some of you may have seen during the first lockdown, there were the European Space Agency published some images of how the air quality improved, in particular over northern Italy, as the traffic came to a halt. So those are the data sets that we will look more detailed into. We'll also look at California in the US, where you have forest fires, for example, influencing air quality. And then in South Africa, we'll look more towards the region around Johannesburg, which also has issues with air quality. And the data that you will receive are for a season, one season in 2019, in particular the winter season, because that's usually there's less interference of other parameters, other air quality parameters that can influence the quality of a satellite image during the winter season. So just to give you an idea of what data we're looking at now. So the Copernicus Atmosphere Monitoring Service product of particulate matter is a raster data set all over Europe, with some empty fields where you have too many clouds, for example. And then on the right, you have the Sentinel-5P image, which is not as much an image as it is an integrated information over a vertical column, so to really measure air quality or parameters within that column. And so technically, if you're interested in participating, you will find all of the information on the AI4EO platform. You'll be able to register there, access all of the documentation, all of the data sets, and it will also include a leaderboard, so teams can upload their solutions throughout the 3.5 months of the challenge, and compute the accuracy of their solution, and we will also then be showing who is in the lead at the time, and of course a prize catalog, because as a challenge we will also be offering prizes. In terms of the computational power, we've seen that a lot of those challenges, of the teams behind it, they might be students, they might be companies that are already working on AI. So we've opted to have to create an API where you can access the training and the execution datasets, and to leave the option to run your algorithm, to test your algorithm, to train your algorithm, where you will do that. That's up to the teams themselves. But of course, if any cloud computing resources are needed, we have access to a Copernicus DIAS, Data and Information Access Service, which can offer some cloud computing resources. And so we will be giving you the data that you need to use, but for everything else, you're free to use the algorithm that you think is best suited to tackle this challenge, as long as it's related to artificial intelligence, of course. To calculate how well you're doing, how accurate your solution is, we have a few KPIs that we'll be looking into. So we, on our side, will have some ground truth data, some in situ data, for which we can use to calculate the root mean square error or the correlation coefficient of the output data sets that you're uploading. And on the other hand, we also will be using some native data sets of the Copernicus Atmosphere Monitoring Service and of Sentinel-5P to calculate additional parameters. And all of these parameters combined will give a score, and we'll keep tracking that score on the leaderboard throughout the challenge. And you can also, when you upload your solution, you can easily check how well am I doing on all of these different parameters, so you can see where improvements might be needed. And then at the end of the challenge, once everyone has uploaded their solutions, their code, and we have the final score resulting from this calculation, we will also be putting together a jury that will look at the solutions, the quality of the solutions, the usability in different areas, the contribution to open science, and that will then finally result in a final score and a winner of the first AI4EO challenge. I'm giving you some additional ideas on what data sets we're intending to use, which are, you know, if you know a little bit about Earth observation data, we'll be looking at different information data sets. So I've already mentioned the air quality parameters that we'll be providing for you. Then we have some additional parameters, such as aerosol optical depth, or land or optical imagery data from which you can derive land cover, and other land cover data sets that can really serve as a proxy to estimate air quality over those areas. A digital elevation model, because air quality tends to stop not at borders, but at high mountain ranges, for example, and any other parameters, meteorological parameters that can influence the air quality at a given day. When it's raining, for example, you'll have better air quality than on a dry, crisp winter day. And so if you decide to participate in this challenge, we won't leave you empty-handed. We also have some sponsor prizes that will be given to the winners at the end. So there will be 3 winning teams. We'll have a first prize, a second prize, and a third prize. And we're also hoping to have some students participating. So teams that consist of only students are eligible for the best student team prize as well. And as you see, we don't calculate here in euros. It's not a cash prize, but what a winning team will get is points, 30,000, 20,000, 10,000 points. And with those points, you can go to a catalog of prizes that's worth over 200,000 euros and select and fill up your basket with the things that you find interesting, either for continuing your idea, your solution, for continuing any other solution that you're thinking of, up till the moment that you've depleted your points basket. And some of the prizes that we will be offering for this first challenge is, for example, 10,000 euros worth of very high resolution imagery in the One Atlas platform of Airbus. So that's really highly detailed Earth observation imagery that's usually, well, it's commercial imagery and usually very expensive to have if you're intending to work with it. We also have 3 GPUs provided by NVIDIA for some additional cloud computing or computing power. And if you're thinking of further developing your Earth observation idea, the Wikio DS will provide some cloud processing and storage. And those are just some of the main prizes that we have. But in addition, we also offer support to the further technical development of your solution, or to support the market development of your solution, to help you build a company around it, so all of those prizes are available in a nice brochure, so that you really can have a look at it and see what it is that you find interesting and that you would like to use your prize money for, if you're of course one of the lucky winners. So I hope I got you excited about this first AI4EO challenge. As I mentioned, we're opening up in February, but you can already pre-register at AI4EO.eu. So that's a thank you already from me. I believe we're going to the Q&A.
Yes, thank you, Annekatrien, thank you, Nicolas, again. And we do have a lot of questions, so thank you for the deep insight. Like always in this cafe, I'm the first, and then the others the question. So this is directly to Annekatrien. Why did you not, I mean, I'm a typical entrepreneur, I'm coming from grassroots arts. I mean, if I would participate in your challenge, why did you decide against Euro? I mean, why didn't you say you just get some money?
It really is to stimulate the ecosystem as well. So we're hoping that this will not be a standalone challenge, but that we're also through those challenges bringing the AI and the Earth observation community together to continue working on those ideas, those solutions.
Okay, good. This was just because I'm always the first. So now I'm going a little bit back. So Nicolas, if you're ready, Nicolas,
sure.
The ship is, there's a question from Shimei at Rabu. Is the ship from Coral TPU?
Sorry, I didn't get the question.
What's the ship which you had in that satellite?
So can you just repeat?
The ship is the ship from Coral, CORAL TPU. Do you know that?
Sorry, I don't understand at all the question. Can you rephrase, or Annekatrien, can you translate, or whatever? Point to the.
Let me.
I think
So
exactly that ship which you sent, small ship, no? Is that?
Yeah, okay.
Is that from Coral? Coral?
No, it's an Intel. Okay, that's okay. I see. The Myriad, the Myriad is an Intel Movidius chips. So it's made by Intel, and that's a visual processing unit, which is, let's say, more adapted to visual and image analysis tasks. I say.
Okay.
And also why being also quite small and very effective in terms of power consumption, which is also very important for satellite and especially small satellites. And this criteria about the size, but also the consumption are very important.
Okay, thank you. So next, Philip Olbrich. Thanks for the great presentation to Nicolas, to you. AI applications often require local training data. Do you plan to include actors, organizations from the global south in your ecosystem? Or is it restricted to Europe?
No, for the go ahead.
Go ahead.
Sorry, Annekatrien, go please.
Okay.
Ladies first.
Yes, so we have been we have some general data sets from NASA, from ESA that cover the entire world, of course. But we have or we are working together with some local meteorological agencies, for example, who can provide some data sets as well for ground truth information. Yeah.
Okay, good. So thank you. Next one, Pratik Basu. We are going around the world here. Reconstructing S1 images to S2 is basically Sentinel, no? Sentinel-1 to images to Sentinel-2 results in uneven image losses. How does one handle that for commercial applications?
Well, the idea is really to be able to sense from an optical point of view what the radar can image. So the idea actually can be seen more like a style transfer approach, where from the radar images you create an optical that actually makes sense for human brain and human sight actually. So the application can be numerous, especially in the frame of damage assessment, operators analyzing, for example, images. It can be also to have a consistent time series of crops or whatsoever. So it just you just have to imagine the solution, but there may be many of them. Some might be just research, but also operational solution can be found from this kind of research activities.
Okay. So now to Annekatrien Debien. For the challenge, do all participants have to be based in Europe? We sometimes work with teams in the US and India. My company base is in Europe. So can it be teams also from US and India?
Absolutely. We're inviting everyone to participate in the challenge. The only restriction, not necessarily applicable to US and India, might be that, for example, for some Airbus data, there could be some export restrictions for certain countries, but otherwise there's no issue with. We would like to have as many participants as possible from all over the world.
Okay, great. And then from the same person, ESRIN. So any other data from the Copernicus Climate Change Service will be provided for the model? Is there any other data, such as wind forecast? Is there other data?
No, so there will be some meteorological parameters available for the training, but no other data at the moment. We haven't included any other data we've set up the data sets that we believe are necessary for what we think will lead to a good model, together with ECMWF and with ESA. So we hope that all of the data that you need are provided from our side.
Okay, thank you. And now Eric van Mulligen. Again, I think to you, Annekatrien, with respect to the challenge on air quality, is there a data set provided with the actual truth, for instance, ground station values?
So the ground station values are not provided. They're meant for validation from our side. But so we do, wait, let me, you still see my screen, right?
Yes.
Yeah. So what we have, we do have some air quality data that are publicly available over the Europe, the US, and South Africa that are meant for the training of the AI models. The last line in the table.
Okay, thank you. And now Linus Scheibenreif. Thank you very much for the presentation. Regarding the Centennial 5P data, is the idea to downscale the column densities or to infer surface concentrations? Did you get it? I can repeat.
Yeah, could you repeat, please?
Regarding the Centennial 5P data, is the idea to downscale the column densities or to infer surface concentrations?
So the idea is to downscale, but also to really have the downscaling at the surface level. Does that answer the question?
Yeah, I think, but we have to see if he comes back. So, so let's go to the next one as we are closing in. We are now soon at the end of our cafe today. Here is Dagmar, a lady, Dagmar Jarosova. Hi. First level is data collection. Next level, using AI to find solutions. People from different professions have different ways of thinking and communication. Does it help AI in the process understanding? And it's a weird question because I try to understand. The question is, does it help AI in process understanding? It's basically, I think the question is, first level is data collection. Next level, using AI to find solutions. People from different professions have different ways of thinking and communication. So it's maybe not the way one has to go. So it's not, I mean, I think the point is that you have a very clear idea how to do the challenge, right? You want to
Yes, but I think that's also why we believe that getting the two communities, the Earth observation and AI together, will help improve the output of of your solution, because getting those different thinking together will help reach you solutions that you might not have thought of otherwise.
I think that's the question where it goes to. It questions this process. I think you might even could approach the problem in different ways. I think that's more a suggestion here, this question. And here we come. Kian, Merashai, Nicolas, Annekatrien, many thanks for the interesting presentation. Will the slides be shared with us after the session? It would be useful to have them at hand to share with other colleagues. So, question, very simple, are the slides available after the cafe?
Yeah, I think on our side, I think there's no restriction. So for sure.
Great.
Yeah. All of this information will also be available on the AI4EO website as well, especially once the challenge has launched.
Yeah, so normally what I'm doing here in the cafe, just write me an email, I share it with Annekatrien and Nicolas, and they will share with you the presentation. If you really want one, just send me an email, because then it's easier for us. I will share it with the speakers, or send it directly to the speakers, but if you want to go over me because you have my email, just send it to me, I forward, and then it's easy because they also know who's gonna ask, and that's the best way. And there, also the last question, that is really the end. Mario Pitschler, he basically, I think we answered his question. His question was, is there already yet info on the challenges on your website? I think yes, no? Is there already?
There is some information available already, yes. But of course not the datasets themselves yet, or access to the forum or the leaderboard. That will be open once we launch.
Okay. So then again, here we are at the end of our today cafe. And first I want to announce, before we say goodbye, the next cafe, which is tomorrow and the last for 2020. It's really the last. The speaker is Simon Papadopoulos from CERT from Greece. He is also the coordinator organization of AI for Media, with this talk on deepfakes and emerging internet threats and their detection. So if you feel like coming to the last cafe for 2020, it's tomorrow at 3 o'clock at the same time. And again, now I want to say thank you, Annekatrien, thank you. And thank you, Nicolas, thank you, and thank you, everyone.
Our pleasure.
Thank you.
Thank you very much.
Thank you. And see you hopefully one day face to face. Bye-bye. Bye-bye. Thank you.